More than a digital worksheet, presented by BPS IT.
Getting started with STEAM, design thinking, and moving forward.
We will start by taking a brief look at the SAMR model. SAMR stands for Substitution, Augmentation, Modification, Redefinition. The SAMR model offers a method of seeing how computer technology might impact teaching and learning. It also shows a progression that adopters of educational technology often follow as they progress through teaching and learning with technology. Substitution. Computer technology is used to perform the same task as was done before the use of computers. Augmentation. Computer technology offers an effective tool to perform common tasks. Modification. This is the first step over the line between enhancing the traditional going-ons of the classroom and transforming the classroom. Common classroom tasks are being accomplished through the use of computer technology. Redefinition. Computer technology allows for new tasks that were previously inconceivable. Participants will be able to identify ways to direct students in thinking processes related to and developed through STEAM exercises. Finding opportunities to engage students in activities that promote authentic products which connect to careers, interests, and individual challenges.
Parcel 1, Introduction to STEAM.
In the 21st century, scientific and technological innovations have become increasingly important as we face the benefits and challenges of both globalization and a knowledge-based economy. To succeed in the new information-based and highly technological society, students need to develop their capabilities in STEM to a level much beyond what was considered acceptable in the past.
It bridges the ethnic and gender gaps sometimes found in math and science fields. To compete in a global economy, STEM education and careers must be a national priority. Each decision made uses an aspect of STEM to understand implications of a decision. STEM and STEAM education is critical to help the United States remain a world leader. If STEM and STEAM education is not improved, the United States will continue to fall in world rankings with math and science scores and will not be able to maintain its global position. STEAM stands for Science, Technology, Engineering, Arts, and Math. STEAM is an educational approach to learning that uses science, technology, engineering, the arts, and mathematics as an access point for guiding students in inquiry, dialogue, and critical thinking. The end results are students who are taking thoughtful risks, engaging in experimental learning, persist in problem solving, embrace collaboration, and work through the creative process. These are the innovators, educators, leaders, learners of the 21st century.
Previously known as STEM, the inclusion of the arts takes STEM ideas even further. STEAM allows students to connect their learning in these critical areas together with art practices, element, design principles, and standards to provide the whole palette of learning at their disposal. STEAM removes limitations and replaces them with wonder, critique, inquiry, and innovation.
When getting started with STEAM, the first thing that needs to happen is the development of lessons and activities.
Components of a good STEAM lesson.
The engineering design loop should be prevalent. Students can creatively solve a challenge. Ideally, there is collaboration between students. A problem to be solved in the real world. Mathematics and scientific theory should be incorporated into the lesson. Include an aesthetic component in a design. and include a chance for students to share their product. When developing activities or lessons with STEAM, try to include at least two of these components in addition to the aesthetic component. A study in ancient Egypt becomes an engineering, science, and math challenge as students design catapults, even creating a video to bring in technology, allowing students to share what they have learned about history, ancient warfare, and the engineering of their own model catapults. Suddenly, your one lesson is a full STEAM activity using all the pillars of science, technology, engineering, arts, and math. Congratulations, you have the perfect STEAM activity. STEAM activities will certainly have a range of formats and complexity levels. We do not want to limit our student imagination. Tinkering alone could serve as a curiosity gateway to new adventure. Parcel 2. Divergent thinking, convergent thinking, and the design thinking loop. Humans by nature are creative beings. Artistic creativity is a neurological product and a normal function of the brain. Creativity is wrongly thought to be solely the domains of special people or special activities. If imagination is the process of conjuring up ideas that are not present to our senses, and creativity is bringing those ideas to life, then innovation is like creativity for a cause. In other ways, innovation is creativity that benefits others. Innovation takes creativity out of the personal space and thrusts it into the public arena. Innovation is the response to a greater call to action. Divergent thinking is the process of generating many ideas in search of a creative solution. Convergent thinking is the process of narrowing down to one correct answer. The concept exists that people are left or right brain thinkers as seen in the picture here, which can coincide with convergent and divergent thinking processes. Back and forth thinking from divergent to convergent thinking leads to creative solutions, which then can be applied to innovation. Digital technology is an excellent way for students to create. Creative tools are readily available in BPS. Students can create for different reasons, which include instruction, entertainment, innovation, and pleasure. Designing is not a linear process. When you design and make something, you do not think and act in separate sequential steps. The creative process of designing is more like switching back and forth between a thinking, questioning, evaluating mode and an acting, doing mode. These modes have been called active and reflective phases of design, and you constantly move between the two. As you can see here, there are many renditions of the design thinking loop in thinking models. Here is a student-friendly model of the design thinking loop or map often used in BPS IT, adopted from the Global Scholars Program. The process involves brainstorming, planning and designing, creating, testing, revising, repeat, sharing, and showing your product. Using the design thinking loop will aid students in thinking about their own thinking, along with familiarizing them with the full process of developing and finishing an authentic product. This skill benefits the student across all content areas. Here we see students at School 18 using this model to develop products for an after-school invention competition. Students used clothespins to identify what step they were in the design process. Creative fitness is finite. It can be exhausted through the course of a day. Failure is part of the process and should be looked at as a positive. And when you can, try to make career connections. Art is an essential part of the design loop as it shapes and transforms ideas into substance. Art is a tool that can pull from a variety of disciplines to visually represent ideas and concepts. Parcel 3, moving forward. As mentioned earlier, when getting started with STEAM, the first thing that needs to happen is developing lessons and activities. Once you start looking for ways to enhance your lessons with STEM or STEAM, you will realize how easy it is to create interdisciplinary activities that really engage your students. There are many commercial products available for purchase. Getting started with STEAM requires little. Make use of materials that are already around. A robust collection of kits, software, and building materials can be accumulated over time through vendor purchases, donations, finding, or inheriting. Activities can include building from a makerspace, using robotics kits, electronics or circuitry, coding activities, 3D design or 3D printing, creative art projects. Breakout activities can be digital or a hands-on activity. And of course, the freebies. After given teacher center trainings, kits for STEAM are available to be signed out. When can STEAM be integrated? Here you can see photos from Frank A. Sedita School 30 having a STEAM night. Students, parents, and teachers all participated in STEAM activities for an enjoyable evening. An excellent example is at School 50, where STEAM time is built right into the library schedule.
I'm Mike Geyer, I'm the Library Media Specialist at North Park School 50.
A word nerds take on tech tools.
A word nerds take on tech tools.
We have a STEAM program where classes come at least once a cycle, dedicated to learning science, technology, engineering, arts, and math. This is Cubetto, one of the manipulatives that I use in our STEAM gym. The way this works, you have a grid. You're not seeing the whole grid here, but we have part of the grid, and there's different colored spaces, different artwork here. You can see a castle, desert, cityscape, mountain, and there's others. The main objective here is to maneuver Cubetto around. One of the things that I love about Cubetto here is a cute little robot, and you can create a narrative with your students so that there's more of a concrete connection to what exactly we're telling the robot to do and why he's doing it. So his objective will vary on your story, but for instance, if we wanted to have Cubeto here go to the desert, you'd have to program the sequence to go forward, turn right, forward, forward. So use this control box. We've got forward, turn right, forward, forward. Now, you can make a story as elaborate as you want, but once the kids get the hang of it, they'll add their own little details. So all you really have to say is, oh, Cubeto wants to go to the desert, and the kids can kind of fill in the rest of it. So once our program is here, we'll press our button. You'll know it's ready to go because the blue lights are lit up. The other thing that's nice when it doesn't go too fast, so students are able to anticipate the moves, follow along with the blinking light so they know what's coming next and what's happening now. And along with the story, Primo Toys website has a pretty thorough teacher's guide with options for more stories to connect some of these places like the castle, the cityscape, and all that. They also have lesson plans based on grade level and experience, but it is mostly geared pre-K, kindergarten, first grade. It's easy to tie in the story idea, the narrative idea. We can describe Cubeto as a robot. Robots can't think for themselves. You have to do the hard work for them. And they'll only do exactly what you say. Because of the way it moves around the board, and you've got two tactile pieces to it, the students are able to make the connections between their errors as well, too.
A word nerds take on tech tools.
A word nerds take on tech tools.
BPS IT recognizes teachers across the district for their participation and effort towards STEAM. Some resources that are available from BPS are student laptops and iPads, Z-Space computers, 3D printers, the BPS STEAM Study Hall group, instructional technology coaches, and the BPS Teacher Center. Reaching out to STEAM Study Hall can provide additional consultation for getting a STEAM program started in your building.
Right now, the need for STEAM workers is greater than the supply. New York State Department of Labor projects those with STEAM degrees will earn 67% higher wages compared to the median. Teachers throughout BPS run STEAM activities, engaging students across all ages and disciplines. Our research indicates that after students attend a STEAM study hall, their interest in pursuing STEAM-related careers rises by 75%. A young person who embarks on a STEAM career path will find diverse opportunities worldwide, along with excellent wages. Students are showing joy and building self-confidence through the utilization of BPS innovative technologies. Get students interested. Start one today. Contact your ITC.
Exploiting community-based resources is a great way to expose our students to STEAM beyond the classroom.